So good morning everyone. In this lecture we will study the protection system of the overvoltage. First of all, in the previous lectures we have studied about the causes of overvoltages, how the overvoltages occur, why the overvoltages occur. Next, we have studied the types of overvoltages that occurs in the power system, and what are their effects and what are their effects, which one is dangerous, which one is less effective. So, and in the just previous lecture we have studied the phenomena that lightning phenomena that impacts the power system, that how it impacts the power system. So these are the three topics that we had studied. Now, uh, what are the next question, whether there is an instrument, whether there is any instrument so that the power system can be protected. So the answer is yes. Yes, there is a system, there is an instrument that protects the power system. So the first instrument that 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 protects the power system is lightning arrestor, surge diverters, rod gaps. So there are n number of protection devices that protects the power system from the overvoltage. Now the question arises whether there is any kind of instrument which measures the amount of overvoltages that has been that occurs in the lines. So the answer is yes. There the two instruments that are, the first is Clindograph. Cleidonograph. Sorry, it is Cleidonograph. Now, what is Cleidonograph? First of all, let's look into the structure of Cleidonograph. So, this is the line, and an electrode is connected to the line, and then a film is there. Homogeneous insulating material is there, metal is there, and it is grounded. So let us look. This is the line. This is what? This is the electrode. This is the film. This one is the homogeneous insulating material. Plate. This one is the metal, and this is the ground. So what we can say, the Cleidonograph is connected between the line and the ground. Now, what is Cleidonograph? Cleidonograph is an instrument. It is an instrument for the measurement of measurement of surge voltages, on transmission lines caused by light. Okay, so kyldonograph is an instrument that measures the amount of surge voltage present in the transmission line which is caused by the lightning. Now it measures the voltage by means of Lichtenberg figures. This entire figure was given by the scientist Lichtenberg, so this figure has been named after him, that is the Lichtenberg figure. The kyldonograph contains a rounded electrode. Say this is the electrode, this is the rounded electrode connected to the line which surge voltage is to be measured. This is the line of which the surge voltage has to be measured. Now it has been connected with the electrode, and the electrode rests on the emulsion side of the photographic film. This is the photographic film. It is present in the emulsion side of the photographic film, which in turn rests on the smooth surface of the insulating plate. This is the insulating plate, which is the homogeneous insulating material. And now it is again connected with the metal plate, and then it is grounded. Now how it works? The photographic plate, this photographic plate is the photographic plate. It is turned or moved by a clockwork mechanism. Now what is this clockwork mechanism? Clockwork mechanism, the clockwise direction, it is being moved in the clockwise direction. This is the clockwork mechanism for bringing in the element of time. This three assemblies, देखिए ये जो तीनों assemblies हैं ये एक ही बॉक्स में रखे जाते हैं और साइमल्टेनियसली द वोल्टेजेस ऑफ थ्री फेसेस, एक के बाद एक फेसेस का हम लोग वोल्टेज जो है वो नापते हैं, एंड दिस इज हाउ वी गेट द वैल्यू ऑफ द surge amount of surge voltage present in the line. So this is the kyldonograph. Now let us talk about the magnetic link. The next instrument is what? Is the magnetic link. Now the question arises, what is a magnetic link? The magnetic link is an instrument. It is an instrument for the measurement of surge current. It was surge voltage and this is surge current due to light. Okay. So there are two instruments. One measures the amount of surge voltages present on the transmission line, and the other is the measurement of which measures the surge currents due to lighting. Now this magnetic link is how it works. This magnetic link contains a small bundle of laminations. Okay, there are a small number of laminations. Like this are the lamination shapes, this are the laminated sheets, this is how the laminations are. So these are the laminations. These are made of cobalt steel. Now these are inserted in the cylindrical molded plastic container. These are what? These are placed in the cylindrical molded plastic container. Now with open end sealed in, this with the open end sealed in, okay, these are being sealed and opened from one end. It is placed in an unmagnetized state. Now this is placed in an unmagnetized state in the vicinity of conductor. Like see here, if there is a line over here, then it is being placed over here, and then this is how the current gets measured. Now, how it measures the current? When the current flows through the conductor, a magnetic field is set up. Now, once the magnetic field is being set up, which is proportional to the current, the magnetizing force or the field magnetizes the magnetic link, which is placed in the vicinity of the conductor. And then what happens? As it as the current has been passed, the link is left with the residual magnetism. Now what happens once the current passes? Then a residual magnetism is being there, is kept there, जिसको हम लोग, ये जो रेसिडुअल मैग्नेटिज्म है, मैग्नेटिक जो हमारा करंट है, उसको हम लोग मेजर कर लेते हैं और हम लोग का वैल्यू हमको मिल जाती है कि कितना सर्ज करंट लाइटनिंग की वजह से होता है। अब देखिए, ये जो लाइटनिंग की वजह से जो करंट है, इसका जो वैल्यू है, ये कभी भी फिक्स नहीं होता। इट डिपेंड्स अपॉन द लाइटनिंग स्ट्रोक विच हैज बीन ऑकर्ड इन द क्लाउड, और उस लाइटनिंग की वजह से हमारा जो सिस्टम है वो हमारा जो सर्ज करंट है लाइटनिंग की वजह से वो मेजर कर सकता है। सो दिस आर दी टू बेसिक इंस्ट्रूमेंट्स which measures the surge current and the surge voltages of the line which has been affected by the lightning strokes. So now we will go towards the protection of transmission line against direct lightning strokes. The topic is protection of transmission lines against direct lightning strokes. Now, डायरेक्ट लाइटनिंग स्ट्रोक्स जो होते हैं वो सारे वोल्टेजेस जो अलग अलग क्लासेस के हैं वो सारों को डिफ्रेंशिएट कर देते हैं, और जब भी डायरेक्ट लाइटनिंग स्ट्रोक्स आता है हमें लाइन में, तो वोल्टेज अचानक से सेटअप होता है और एक फ्लैशओवर क्रिएट होता है, एक फ्लैशओवर पाथ आता है। जो फ्लैश रहता है वो डायरेक्टली ग्राउंड पे हमारा मूव होता है। ये जो फ्लैशओवर रहता है, ये जैसे जैसे इंसुलेटर का लेंथ बढ़ता है वैसे वैसे हायर वोल्टेज का फ्लैशओवर ऑकर होता है। तो इसका सबसे प्रोडक्टिव मेथड है कि फ्लैशओवर्स को अवॉइड करना या लाइन इंसुलेटर का ब्रेकडाउन होने से हमको बचाना। तो जो दो मेथड्स हैं, या तो हम लोग फ्लैशओवर को अवॉइड करें, लेकिन क्या हम लोग फ्लैशओवर को अवॉइड कर सकते हैं? नहीं कर सकते। और क्या हम लोग इंसुलेटर्स को ब्रेकडाउन होने से रोक सकते हैं? हो सकता है कि हम लोग देख सकें। तो जो सबसे ज़्यादा एक्सेप्टेड और इफेक्टिव मेथड है वो है ओवरहेड ग्राउंड वायर्स का यूज़ करना। तो ये जो ओवरहेड ग्राउंड वायर्स होते हैं, ये हम लोग का एक शील्डिंग मेथड क्रिएट करते हैं। ये एक हम लोग का एक जो फ्लैशओवर जो होता है जिसमें कि आर्क बनता है, उस आर्क को अवॉइड करने के लिए हम लोग इस शील्डिंग मेथड का यूज़ करते हैं और ओवरहेड ग्राउंड वायर्स हम लोग इसमें लगाते हैं। अभी जो ग्राउंड वायर्स हैं, ये जो हमारा मेन कंडक्टर्स हैं ट्रांसमिशन लाइन के, उसके पैरेलली कनेक्टेड होता है सेम टावर में, ठीक है। और ये जो हमारे वायर्स हैं, ये हमारे गैल्वेनाइज्ड स्टील वायर्स होते हैं या तो ACSR कंडक्टर्स होते हैं। इनमें शील्ड लाइन्स हम लोग प्रोवाइड करते हैं ताकि डायरेक्ट जो स्ट्रोक्स हैं वो इसको अट्रैक्ट ना कर सके, और अगर कभी भी वो स्ट्राइक करने की कोशिश करता है तो वो उसको ग्राउंड से कनेक्ट कर दे ताकि वो तुरंत हमारा जो है वो ग्राउंड में चले जाए। सो दिस इज हाउ वी हम लोग अपने ट्रांसमिशन लाइन को protection करते हैं against the direct lightning strokes. So in this lecture we had studied about the types of measuring instruments which measures the surge voltages and the surge currents present in the transmission line, and we had also studied how the what are the protection of transmission line against the direct lightning strokes. So in the next lecture we will study the protections of stations and substations from the direct strokes.